let's get you prepared for this first aluminum recycling lab. The purpose of this lab is to take a waste piece of aluminum foil and recycle it or change it into something else. Aluminum is one of the most commonly recycled materials, and the reason being is because you cannot find aluminum in its elemental form anywhere in the world. It exists in bauxite, a type of ore that contains aluminum oxide. There are no significant bauxite deposits in the U.S. They are mostly in Australia and places like Jamaica and Africa. And just importing those materials and then using the energy to refine the bauxite down to aluminum takes a lot of energy and costs a lot of money. So producing one new aluminum can will cost just as much as producing 20 recycled aluminum cans. So you can see it's much more efficient to recycle the aluminum. Anytime you are completing a lab in this class, it is a terrific idea to read and follow the instructions carefully, and also to read ahead. If your partner is doing one step, you should be reading ahead and seeing if you can complete the next step or a step further down the road while you're waiting. Step 4 tells you to get approximately 55 milliliters of water. So don't sit there and try to specifically measure out 55 milliliters, just get about 55 milliliters. Now, when using the sinks for the first time, you're going to notice that they're not ordinary sinks. These are called gravity assist faucets. Students get confused because they try to shut them off and they don't turn off all the way, and so they try to tighten it up even tighter and they end up breaking the faucet. So the rule in chemistry is snug but not tight. Let me show this to you. You can see that the water keeps running after you turn the faucet off, but eventually it comes to a stop. So don't freak out if you think the water's not turning off. It'll eventually turn off. That's just the way the faucets are. In step 7, you'll be using a thermometer for the first time in this class. We'll use thermometers quite a bit. The thermometers we have can be read to the tenths place or 1 decimal place. So for example, if you have a temperature reading like the one shown here, the most common mistake students would make was reporting, okay, the temperature is 100. Well, that is not correct because you need to read it to the tenths place. So the actual temperature is 100.0 degrees Celsius. So take a look at another example. All right, if we're looking here, we have 20 and then 30. So each one is a degree here. So 21, 22, 23, 24, 25, 26, 27, 28. Looks like it's about halfway in between. The temperature here would be 28.5 degrees Celsius. All right, take a look at this one, and how would you report that temperature? Just think about it real quick. If you said 49, that is not right. Remember, we need a decimal place in there. We can read these to the tenths place. The correct temperature is 49.0 degrees Celsius. Okay, try one more. What is the temperature reading here? All right, looks like it's somewhere in between 63 and 64. Maybe we read it as 63.6 degrees Celsius. Doesn't really matter what that decimal place is as long as it's there. Without some support, our thermometer will tip over our beaker and cause some spillage or breakage, so make sure to use the funnel holder to help support your thermometer when it's sitting in the beaker. In step 10, it says to use the think tank to decant the liquid in your beaker. The think tank is in the east hood. It's just this 5-gallon bucket labeled think tank. For step 12, you have to do some filtering. So you need to fold a piece of filter paper so it can fit into the funnel that we have. And we're going to do a little origami. And we're going to do taco origami and pizza origami. Kind of like this. With your filter paper as a little cup there, that'll fit right into the funnel, get a little wet, and it'll stick in there. You are now ready to do the lab. Get your goggles on and go. When you are all done, complete the questions in the lab and then return to this video and I will give you some help on the post-lab questions. Make sure you've at least attempted the post-lab questions before watching the rest of this video that discusses those questions. The first question we're going to talk about is, what is the reddish solid? Hopefully you took a guess or two about what it might be. Here's how you do it specifically. First thing you want to do is list out the chemicals that were used in the lab. Well, the first thing you did was get 55 milliliters of water. So water was the first chemical you used. To the water you added some copper chloride, CuCl2, and then made a solution. So to the solution you added a piece of aluminum. Those are the chemicals that were used in the lab. What we want to do is take the chemicals and list the atoms that make up those chemicals. So you can see that water is made from hydrogen and oxygen, so H and O. Copper chloride is made from copper and chlorine, and aluminum is just aluminum. This is chemistry class. When we do reactions in chemistry, you cannot make any new elements. It's not a nuclear reaction. This isn't physics, okay? We're not changing the identity of atoms. Whatever atoms you have to start with, that's the atoms you have to finish with. You can't make anything new. So in that whole list of things, whatever your guesses were, they have to be something that contains these atoms. And the actual answer, what the substance is, it's just copper metal. That's all you made. Okay, so a good question would be, where the heck is the aluminum then? If the solid in my filter paper is copper, where'd the aluminum go? So think about that real quick. If you can't get it, maybe a chemical reaction will help you. So here's what happened in reaction form. So we took some aluminum in its solid form and we added it to copper chloride as a solution. That's what AQ means. And we know we got some copper solid. So what's left? What happens is the aluminum and the copper switch places. So if the copper becomes isolated by itself, then the aluminum and chlorine are going to match up. And that makes aluminum chloride. And it would be aqueous or dissolved in solution. So that's one hint about where the aluminum might be. So where's the physical location of the aluminum right now? Think about that. And if you're struggling, look at step 10. After the reaction was complete, you took the beaker over to the think tank and you dumped out that liquid. Well, the liquid contained aluminum chloride. So right now, the aluminum is in the think tank. Okay, so you should also have observed bubbles during the reaction. Well, what are the bubbles? What gas is in there? You do the same sort of thing here. The gas that forms has to be composed of the atoms that are available. This isn't physics. We didn't do a nuclear reaction and change one type of atom into another type of atom. Whatever atoms we started with, that's the atoms we finished with. Okay, so what are some guesses that you could have? Okay, well, you should be able to eliminate copper. It's not copper gas because we made copper metal. Maybe it's CO2. That's a common guess. Well, it can't be CO2 because CO2 is composed of carbon and oxygen, and there are no carbon atoms in our list. So it's not CO2. Well, maybe it's Cl2. Maybe it's chlorine gas. Well, maybe, but it's not. I'm going to tell you because you would notice chlorine gas has a terrible odor, and it has a yellowish-green appearance, and we didn't see that, so it's not chlorine gas. So another guess, maybe it's aluminum gas. Well, it's not aluminum gas either. Aluminum is a metal, so it's going to have a very high boiling point, and it won't turn into a gas very easily, not in conditions we can get in our laboratory. So it's not aluminum gas. So it's either hydrogen gas or oxygen gas. So what do we do in chemistry to determine what a gas is? We do a flame test. We're going to do a flame test on the gas from lab and see what gas it was. Before we can do that, I need to show you what a flame test for oxygen and hydrogen gas look like. Then we will flame test the gas from lab and determine whether it's oxygen or hydrogen gas. So here we go. You can see oxygen gas reignites the splint that I'm putting in there. Here's the flame test for hydrogen gas. You can see it makes a loud popping sound. Now we're going to test the gas from the experiment. Oh, nice popping sound. That means the gas generated in the experiment was hydrogen gas.